Hey guys, so in today's lesson, we're going to be talking about polynomial functions and rates of change. You're going to need station 1 and something to write with. And then for this lesson, you're going to need to have an understanding of the parts of the polynomial expression. So like leading term and degree. Okay, if you're not familiar with what those are, I recommend that you go watch the video on Intro to Polynomials before you do this lesson. Okay, so let's start. We know a polynomial is just an expression that has many terms. The exponents for the x values must be positive, and we cannot have any variables as exponents. The graphs of polynomials are going to be smooth and continuous. So this is an example of a polynomial function. Notice that it's smooth and continuous. Okay, so even though we don't know the equation, we know that this graph represents a polynomial because of the characteristics, it being smooth and continuous. All right, so there's going to be sections of the AP exam where you're not able to use a calculator. So we're going to have to know the characteristics of certain graphs so that we can answer our questions correctly. And we're going to be starting that process today. Just some clarifications. We already reviewed Extrema, relative and absolute max, but I want to define it the way that the AP exam defines it. If a polynomial switches from increasing to decreasing, then there's going to be a maximum value. So if the graph is going from up to down, there's going to be a peak at the top, and we know that that's going to be some sort of maximum. And that maximum can either be relative or local, or absolute or global. Next, if a polynomial switches from decreasing to increasing, then we know that there's going to be a minimum output value. All right, and this minimum value can either be relative, local, or absolute. So I wanted to provide some clarification on endpoints because we didn't get a chance to discuss that in the old videos. You can have maximums or minimums at the endpoints of functions only if the point is included. So when I say included, I mean that the point is a closed circle. So looking at this example, point A would be a relative maximum because it's trending upwards. And point A is the high point in that particular section of the graph. But point D would not be considered a minimum because it is not included in the graph. We have an open circle at point D. Okay? All right, so now let's move on to example number 1. All right, find the extrema where they occur. If there are none, write NA. All right, so we have this graph here. And notice that this graph cannot represent a polynomial function because there are sharp turns at point C and D. So just tying that in there. You should be able to do this. I'm just going to give you a tip. Remember that a relative max or min can also be an absolute max or min. So keep that in mind when answering. So I would like you to pause the video and try to get the answers on your own before coming back and checking in. Okay, so for part A, the absolute min, we don't have an absolute min because we have that arrow at the end that's going to be going down, down, down forever. So there is no absolute min. Part B, the absolute max, it's going to be at point F. That's the highest point on the entire graph. C, relative min. So it's a low point intersection of the graph. So we have a relative min at B, as in boy, and then we also have a relative min at D, as in dog. And then the final part, a relative max. We have a relative max at point A. So I know it's an endpoint, but we're going to include that endpoint because it is a high point in that section. And then we have F, which is the absolute max. But remember, an absolute max can also be a relative max. And we also have one at C. Okay, so moving on to this next concept. And this is going to help us when we don't have a calculator. If you have 2 consecutive zeros of a non-constant polynomial. So when I say non-constant, I mean that the degree of the polynomial is at least 2. Okay, so when you have 2 consecutive zeros of a non-constant polynomial, then there must be at least one relative maximum or minimum between the 2 zeros. Okay, so I know this is kind of conceptual, so let's look at an example. So in this example, we have a polynomial and we have 2 zeros, okay? And notice that in between the 2 zeros here, that we have a minimum point in between the 2 zeros. So there are times where you can have more than one relative max or min between 2 zeros. Like in this example, we have a max, then a min, and then another max before hitting the other zero. But at the very least, we always know that there's going to be at least one maximum or minimum between the 2 zeros. So let's move on to example number 2. It says, let f of x be a polynomial with values f of -1 equals 0, f of 0 equals 2, and f of 4 equals 0. Are there any guaranteed extrema? If so, state the interval where it must occur. We can make this question a bit easier if we kind of annotate. So let's go through this. So f of -1 equals 0. That is just telling me my x and y values. So essentially, I have 3 different points. So f of -1 equals 0 means that we have a coordinate at -1, 0. F of 0 equals 2 means that we have a coordinate at 0, 2. And then f of 4 equal to 0 means that we have a coordinate at 4, 0. Okay, and we have a graph there where we can plot these points. So I'm going to plot these points now. And the question is asking, are there any guaranteed extrema? So remember, extrema is just your relative or absolute max or mins. And if so, we need to state where it's happening, the interval where they must happen. So I plotted my points. So 2 of my points are zeros and the other point is a y-intercept. So I see that I have 2 consecutive zeros, which means there must be at least 1 maximum or minimum between these 2 points. So our answer is there is at least 1 guaranteed extrema, and it must happen between -1 and 4. For the next section, we're going to be talking about even degrees. Polynomials that have even degrees have very specific characteristics, along with polynomials that have odd degrees. They have very specific characteristics. So on the screen, I have 3 different examples of polynomials that have an even degree. Notice that both sides are either pointing upwards or downwards. And then here I have 3 examples of polynomials that have odd degrees. Notice that one side is pointing upwards, the other side is pointing downwards, or vice versa. So in this next section, we're going to be talking about even degrees and what happens to the extrema. Okay, so for leading coefficient, in that column where it says positive, we're just going to make an example. So let's say y equals 3x squared. And then we want to sketch the graph. We don't need to put the exact points. Notice that that graph doesn't have any numbers. We just want to sketch it. So when we have a positive leading coefficient, we're going to have a parabola that's a U-shaped and the arrows are going to be pointed upwards. And then the type of absolute extrema that it makes is an absolute min. We have an absolute min in the middle at 0, 0. So now negative. So we're going to take the same function and make it have a negative leading coefficient. So for negative, we have y equals to -3x squared. And when we sketch that, notice that the arrows are pointing downwards. It's kind of flipped. It's now pointing downwards, which creates our absolute max. Let's create a rule. All even degree polynomials with a positive leading coefficient will have an absolute min. And then all even degree polynomials with a negative leading coefficient will have an absolute max. Okay? And just FYI, this is not going to be true for polynomials that have odd degrees because we're never going to have an absolute max or a min because the graph always goes on in both directions. So now let's get into example number 3. Without the use of a calculator, determine if there's an absolute max or min for each function. If there is, state how you know. So for part A, we have f of x equals to all of that. The first thing I'm going to check for is to see if my polynomial is in standard form. So this function is in standard form, which means my degree is 4. So my degree is even. So I know that there's going to be an absolute max or min. Now, looking at my leading coefficient, I see that it is positive. So since my leading coefficient is positive and I have an even degree, that means I must have an absolute min. Question B. So we have g of x equals to 4x squared minus 6 minus x to the 5th power. This is not in standard form, so make sure you're paying attention to that. The term that has the highest or greatest degree or exponent is negative x to the 5th power. So my degree is 5, which makes it an odd polynomial, which means there is no absolute max or min for this function, okay, because I have an odd degree. So for question C, I'd like you to try this one on your own. Question C says h of x equals to negative 7x minus 3x squared plus 4. This is not in standard form, so I have to be careful when identifying my degree. I see that the greatest exponent is 2, which means my degree is 2, and that's going to be an even polynomial, which means I must have an absolute max or min. Now we need to look at the leading coefficient. So I see that my leading coefficient is -3, and it's negative, which means since my polynomial has an even degree and the leading coefficient is negative, I'm going to have an absolute max. Okay, so that is all from me for today. Please let me know if you have any questions before moving on to station 2.